On week 1. So we are still on week 1. We want to look at how can we find the antilogarithms of numbers, that is the opposite of logarithms. How can we find the antilogarithms of numbers using the 4-figure table? All right, let's look at the first example. How can we find the antilog of 2.4578? Please take note. This first number here denotes the number of places where the decimal point is to be. That is the position of the decimal point. Please take note. I repeat, this first number represents the position of the decimal point in your final answer. While after the decimal point, this is what you are going to use to check. This is what you are going to check from the table. From the table, you are going to check 0.45 difference under 7 difference 8. I repeat, from the table, you are going to check 0.45 under 7 difference 8. Now, let's look at how to use the table over there. So this is the antilogarithms of number tables. So we want to check 4.45. So this is your 0.45 under 7. So this is 0.45 under 7. This is under 7. This is the 7. So 0.45 under 7 is 2864. That will give us 2864 plus 0.45 under 7, now difference 8. So we add the difference. So let's go and check difference 8. Difference 8 is 5. This is difference 8. So difference 8 is 5, so we are adding 5. So plus 5. This will give us 9, 6, 8, 2. So we have 2869 to be the antilog of 0.45 under 7 difference 8. Now, let's make use of these 2. These 2, I told you earlier that it represents the position of the decimal point. So this means that the decimal point will be placed, at 3 numbers. I repeat, 3 numbers. That is, any number that is here, you add 1 to it. If it is 2, you add 1, it will be 3. If it is 3, you add 1, it will be 4. If it is 0, you add 1, it will be 1. So this is 2, you add 1, that makes it 3. Meaning that it's going to be 3 numbers before the decimal point. So this is the number, 286. So after these first 3 numbers, then you place your decimal point. This shows that the antilog of 2.4578 is 286.9. This is the first example. Now let's look at the second example to explain more on this. Now this is it. I repeat, this first number here represents the position of the decimal point. While what you are going to check from the table is going to be 0.71 under 9 difference 2. So let's go to the table now and check. Now the table 0.71. So this is the antilogarithm tables. So 0.71 under 9. This is under 9. This is 9. That is 5236. So we come back here, 5236 plus, that is, you add the difference. This is 0.71 under 9. Then difference 2. So let's go and check for difference 2 in the table. This is 0.71 under 9 difference 2. This is 2. Difference 2 is still 2. Difference 2 is 2. So we come back here and add the 2. That will give us 6 plus 8. 6 plus 2, 8. Then 3, 5. I repeat, this 0 represents the position of the decimal point. So you add 1 to it, like I said in the first example. Any number here, you add 1 to the number. So this is 0, you add 1 to 0, it becomes 1. That means that the decimal point is going to be what? 1 after the first number. So this is the first number, so you are going to place your decimal point here. Let me repeat on this. If the number here is, for example, 1, if you add 1, it's going to be 2. That means you are going to count 2 numbers before the decimal point. So this, since it is 0 now, you add 1 to it, that will be 1. That means you are going to count 1 before you place your decimal point. This shows that the antilog of 0.7192 is 5.238. Still on antilogarithms, let's find the antilog of this number. Question 3, 3.4684. This first number indicates the position of your decimal point. So we'll leave this. So in the table, in the antilog table, you check 0.46 under 8, difference 4. Check 0.46 under 8, difference 4. So let's go to the table now and check. So this is the table, 0.46 under 8. So this is 8. This is under 8. Under 8 is 2938. So we come back here, 2938 plus, so you add the difference, which is 4. This is 0.46 under 8, then difference 4. Let's go and check for difference 4. Difference 4, 0.46 under 8, difference 4. Difference 4 is 3. This is difference 4. So difference 4 is 3. So we come back here and add the 3 to it. Then we had 8 plus 3, 11. Carry 1. 1 plus 3, 4, 9, and 2. Lastly, then the 3 represents the position of your decimal point. So you add 1 to this 3, as we did for the rest. So 1 plus 3, that will be what? 4. 4 means you are going to count 4 numbers before your decimal point. So let's count 4 numbers. 1, 2, 3, 4. That is the complete 4 numbers before your decimal point. That means the answer still remains 2941. So you don't need to put any decimal point, since we still have it to be 4 numbers. So this is the revision on antilogarithm tables in our lesson 3. So in our lesson 4, we will now look at the practical application of how to make use of logarithm tables to multiply numbers and to divide numbers. Thank you.